Hello, kidlets. So since Mrs. Crawford and I are both out, you've got to watch a quick video today on lesson 2. So in your purple notes packet, which is the lighter colored purple packet, please find page 6. And I'm just going to give you 2 examples out of the notes. You're going to watch these examples and then do 2 nearly identical examples in your homework packet, I believe also on page 6. All right, so find your notes packet and open to page 6, and we'll get moving. So, leading up to this, you have all been learning properties of parallelograms and rhombuses and rectangles. And what we're going to do now is take those properties and apply them to a graph. So, if I know that like opposite sides are equal, how would I show that on a graph? Well, let's see. If I want to prove, really just like show, that I have a parallelogram that's graphed on a grid, one way I could do that is by saying both pairs of opposite sides are congruent. Well, congruent just means same length. So if I'm on a graph, I can show that sides are congruent by finding the length using Pythagorean theorem. And that's that a squared plus b squared equals c squared thing. So I can show something's a parallelogram by showing that opposite sides are equal, find all their lengths, and show that they're the same. Another thing I can do on a graph is if I want to show that both pairs of opposite sides are parallel, when I'm on a graph, when I'm using coordinates, and I want to show that things with coordinates are parallel things have equal slopes. So what I can do is show that I have a shape that has 2 pairs of equal slopes. So that's actually how we're going to start. We're only doing these first 2. So I know I'm leaving the other 2 blank. It's okay. So if I come down here, and this question says, prove that Kyle with the given vertices is a parallelogram by showing that both pairs of opposite sides are parallel. First thing I got to do is, graph Kyle so I can see if it even looks like a parallelogram. So plot with me and label all your points. So there's K, Y, L, and E. There's Kyle. Now, I'm telling you that we're supposed to prove that it's a parallelogram. Other than my eyeballs tell me, yeah, it looks like a parallelogram. How can I prove that that's true? Well, I'm telling you this time how to prove that it's true. We're going to prove that both pairs of opposite sides are parallel. How am I going to do that? I'm going to show that I have opposite sides with equal slopes. Parallel things have equal slopes. So I'm going to count out the slopes. I'm going to switch colors. All right. So if I want to do the slope of all 4 sides, I should actually list the sides first. I need to show the slopes of all 4 sides. So KY, YL, LE, KYYL, LE, and EK. So those are the 4 sides. And we're going to list the slopes. So if I want the slope of KY, I'm going to draw in my rise over run. So I went up 2, right 1. So my slope is 2 over 1. And we're going to want to simplify slope here, okay? Just trust me on that. It makes more of an impact later. 2 divided by 1 is 2. Then YL. Well, YL is flat. It's horizontal. A horizontal line has a slope of 0. And then LE. Well, if I draw in my rise and my run for LE, I'm going down to left 1. And negative 2 divided by negative 1 is 2 again. And then last but not least, EK is another horizontal segment, so that has a slope of 0. And what you should be noticing is I have 2 slopes of 2 and 2 slopes of 0. So those are equal slopes, making those sides parallel. Now, we have to explicitly say that using basically 3 parts, okay? These aren't going to be full sentences, but each sentence or group of sentences has to have 3 parts. Part number 1, what did you notice with the numbers? Well, I noticed that with the numbers, 2 pairs of slopes are equal. Okay, so thing number 1 is, what's your observation about the numbers? And our observation about the numbers is that those numbers are equal, showing me some equal slopes. Then we have to say, wait a second, geometrically, what does it mean if slopes are equal? Well, equal slopes means parallel. So 2 pairs of slopes are equal. Pardon me, my dog wants me to play with her. 2 pairs of slopes are equal. Therefore, opposite sides, and it's both pairs. So both pairs of opposite sides are parallel. Then the last step is, okay, so if you have a shape where both pairs of opposite sides are parallel, what kind of shape it is? It's a parallelogram. Okay? And there it is. That's how you do what's called a coordinate proof. You are given a shape, and then you are asked, prove that this shape is what you think it is using coordinate geometry. Slope, midpoint, distance, length, Pythagorean theorem, whatever. Do some geometry to get there. All right, we're going to do one more. Now, what we just did is one way of proving something's a parallelogram. There are 4 different ways. We're going to show 2 of them. All right. So option 1 is that things are parallelograms if you can show that opposite sides are parallel. Option number 2 is you can show that something's a parallelogram by showing that both pairs of opposite sides are congruent, are equal in length. Well, if I need to know whether things are equal in length, the coordinate formulas I need to figure out are, what are the lengths of all the sides? Well, I need the length of AB and then the rest of them. Now, I'm just going to leave this blank right now because I don't know how big my writing is going to be, but we're going to find all 4 lengths, starting with AB. Well, if I want to find length on a coordinate grid, the first thing we're going to do, I'll use a brighter color here so it's more obvious what I'm drawing. The first thing I'm going to do is draw in my rise and my run from A to B. So I went up 2 over 5, right 5, okay? But instead of calculating slope this time, I'm going to make a right triangle out of that and say, wait a second, I can use the rise and the run to calculate slope, but I can also use the rise and the run to calculate length by doing a squared plus b squared equals c squared. So 2 squared plus 5 squared equals c squared. That's 4 plus 25, which is 29. And then if I want to solve that, I'm going to square root it. And I get, let's see, the square root of 29 is 5.38. I'm going to round that to 5.4. So AB is 5.4. All right. Now let's come over here and do BC next. So BC, I'm counting over 3, down 3. And so I'm going to do a squared plus b squared equals c squared. 3 squared plus 3 squared equals c squared. Well, 3 squared is 9. 9 plus 9 is 18. And if I square root that to solve for c, I have that one done already. The square root of 18 is 4.2. And now I know that BC is 4.2. And you might be thinking, Mrs. Weber, wait, we don't have enough space. Yeah, we do, because watch this. Isn't BC the same length as AD? Aren't these sides going to be congruent? Let's check. Down 3, over 3. Hey, look at that. It's the same purple triangle. So BC is 4.2 and AD is 4.2. And if I go from C to D, that's down to over 5. Just like the other green one we had, AB and CD are both 5.4. So what did I notice? I noticed I have two 4.2s and two 5.4s. So I'm going to draw my 3 dots so I make sure I have everything I need in my conclusion. Okay. 2 pairs of lengths are equal. Therefore, opposite sides are congruent, because equal length means congruent length. Therefore, what is this thing? ABCD is a parallelogram. Okay. So what did we just learn? You just learned that you can do a coordinate geometry proof by saying, okay, if I want to show that something's a parallelogram, I need to find either all 4 lengths, or I could do it by finding all 4 slopes and showing that either 2 pairs of opposite sides are parallel, or by showing 2 pairs of opposite sides congruent, and then you've got a parallelogram. Okay. Now, I want you to keep this open and work on your homework. I believe it's also on page 6, and you're just doing the homework on page 6, question 1 and question 2. They are exactly the same as what we just did, but with different numbers. Okay, nearly identical, just different numbers. All right, I hope that you guys all have a good rest of your afternoon. Stay dry. It's a little rainy out there, and I'll see you soon. Bye.